Hello, I'm Eduardo and I'm a senior engineer at Akka. In this video, I'll be introducing Akka's new agent component available from Akka SDK version 3.4.0. So let's start by giving you a quick overview of the features this component has to offer. With Agent Component, you can easily integrate large language models into your applications. It supports different LLM providers, so you're not locked into a single vendor. So agents come with memory out of the box, allowing them to maintain context across conversations and provide more coherent responses. You can use system message templating to dynamically control the AI's behavior and context, making your prompts more flexible and maintainable. Also, response transformation is built in, so you can easily map AI outputs to structured data, custom formats in your Java application. We also introduced support for function tools, enabling the AI to call your own business logic or external APIs as part of its reasoning process. Retrieval-Augmented Generation, or RAG, is supported as well, letting you enrich prompts with relevant data from your own sources. So for real-time applications, agents also provide streaming in and out so you can deliver responses to users as they're generated. You can also orchestrate multiple agents together for more complex workflows, enabling multi-agent collaboration to solve advanced tasks. Finally, the agent component is designed for seamless integration with your other Akka components, making it easy to add AI capabilities to your current services. So here we have a very simple agent that receives requests from an endpoint. So basically I have two classes. Okay, so one is this endpoint declared to be able to be accessed from the internet, and we say it must be available at the hello path, and then we also define this hello world method available as a get request, and in here we use our component client to send a message to an agent within a specific session. We'll talk a little bit later what the session is about. And on this agent, we'll call the ask method and basically pass this parameter hello world is our message. So our agent is also fairly simple. We need to extend this agent class and we need to declare a component ID. And then we need to have a public method that receives the message and returns the construction of the call that we want to do to the LLM. So here we're saying that we want to use this system message, your helpful assistant, and then this specific user message that comes from the endpoint, and that's it, basically. So let's try this out. So I'll run this here, and then I'll run this curl command. Hello, I can assist you. How can I assist you today? Is the response. Okay, fair enough. So now let's actually change our endpoint a little bit and add this post endpoint instead that allows us to actually send a customized message. Call it ask, and we need to receive something here. So this will be the body of the post. Okay. Question. Something like this, and then here we will obviously pass in the message. So pretty similar to what we did here, but now we're just receiving our message from the body of the request and then passing it on to the LLM. Okay, so let's try this one. We start the service. Okay. Okay. Okay, so I sent this message, hello, I'm Eduardo, and it replied with, hello, Eduardo, I can now assist you today. Now, if I send a follow-up message, what is my name? I'm sorry, but I don't have access to personal information. So, of course, the model doesn't know my name. So, what is actually happening? So, basically, when we do this post request, we're obviously doing it to our hello world endpoint, and then it gets redirected or call is made to our my agent. Note that here to do this call, we're using this component client. So this is actually a very interesting feature from the Akka SDK, which is a component or a client that allows you to call different components in your service. And this is very important because these entities actually can be in a different node. So that's why this component client is very important. Anyway, so we're calling the my agent, and then we also send from the agent send the system and user message to the LLM model. From the LLM model, we receive the AI response and then send it back to the user. So we see we have these two small components from the Akka SDK that do the interaction with the LLM model. Important thing to notice here is that, as we just saw, the LLM doesn't have any memory. So we need to actually provide it with the memory. And that's what the Akka SDK does. So the session memory is what allows the agent to have access to the entire conversation history between the user and LLM. This persistent record enables more coherent and context-aware responses as the interaction progresses. There are several types of session memory configurations available to suit different use cases. For example, a limited window memory only retains the most recent messages, which helps control resource usage or token limits. Alternatively, memory can also be configured as read-only or write-only, or even disabled entirely for certain agents. You can also implement a custom memory provider. Also, this interesting feature about subscribing to memory updates proves useful for building analytics, monitoring tools, or triggering additional workflows based on conversation events. Session memory is not limited to a single agent. It can be shared among multiple agents participating in the same session. And by using a common session ID, different agents can access and contribute to the same conversation history. This shared context enables collaborative multi-agent workflows where agents can build on each other's knowledge and actions to achieve more complex goals. Okay, so let's try this out. Actually, so let's start by modifying our agent to have maybe a more interesting prompt, I'd say. So we'll do it like this. So I'll have this, let's play a game. Each of us must reply in a new language every time. The first one to use a repeated language to reply loses. Defend the name of the language you are using. Try not to lose. Okay. Now, one interesting thing we need to do as well is to actually provide the session. So we see here that we are actually using a random session. So that is why our agent is not able to remember the things from the past conversation because we're generating a new session every time. So let's actually receive a session here. I'll add a new parameter and use that parameter as a session, our session. So let's try this now. We'll put this. Okay, so I'll send first message in English. Okay, replied in Spanish, so I cannot send it in Spanish now. I'll send it in Portuguese. Okay, so it replied in French, and now, okay, let me try it in Italian maybe. Okay, let me send a message in it. Okay, it replied in Japanese. So as you can see, it actually tries to always use a different language to reply. So now if I send another Italian, you have repeated the language, I win. Okay, cool. So this is very interesting because it's clearly that the model is able to know exactly what were the previous languages that were used and is trying to always use a different language. And actually, to make it obvious that that's happening, we can say we can disable the memory. And so if we run it like this, we just define memory none, and now it will be fairly easy to see that the memory will always generate, or typically generate the same reply, so it always replies it. Now it changed to French, but yeah, it clearly doesn't remember exactly what language it used previously. So this is the way that you can define different types of memory or disable the memory. Another option that we offer is, for instance, write only. So this option basically allows the conversation to be stored in the session memory, but the history is not passed to the LLM when requesting a response. And on the contrary, you also provide the read-only option, where the LLM will be provided with the session memory, but the result of this interaction will not be stored there. This is actually useful, maybe in the context where different agents are sharing the same session memory, but each of those have different roles, have a different role in this session. So maybe some of them will only be reading the session and others will write. We can also say that we only want to read the last X amount of messages, for instance, and some other options available. Okay, cool. So let's see what is actually going on. So again, we are sending a post request to this endpoint, received by the endpoint, and the endpoint is sending that to the my agent. Now, as we see here, we're first retrieving the session history from this session memory entity, and then we receive the previous messages, and then when we interact with the model, we send not only the system and user messages, but also the history of messages. So the SDK is actually responsible for providing this context to the LLM. Otherwise, the LLM has no capabilities to know the history. And then the LLM will respond back to the agent, and the agent will store the result of this interaction, and then will reply back to the client. Let's have a look at another very interesting feature, the function tool calls. This function tool calls allows you to extend the model capabilities. So by providing the model with different tools that can be executed automatically by the SDK. So note that it's not exactly the model that executes those tools, but the model will be able to actually request access, request those tools to be executed, and then the SDK will do that upon request. So let's see an example actually. So let's change our agent and declare a function tool. I'll need to give it a name. So I'll declare here a function tool to declare a winner. So the goal is that when the model detects that someone has lost this language game, it should call this tool to declare the winner. So yeah, I'm declaring a new function tool with the name declare winner, and the description I'll say use this tool when you found the winner for the game. And it's probably good to say as well, the winner can be the user or the assistant. Yeah, something like this. Okay, so, and now we can just have some very basic function here. I'll just log something. So I'll say log info. The winner is yes. Okay. And then I'll have win. Yeah. So this tool will have a parameter. Yeah, so very simple tool. We just declare it. So since we are declaring this tool inside the agent, it will be automatically be included on the tool call, on the agent call. But this function could also be declared outside the agent if you want to reuse it, for instance. So let's try this out actually. So I'll restart the service. And then I'll do a call in Portuguese, replied in French, and now I'll do another one in Portuguese. So the model will say, you used Portuguese again, which means you lost the game. Thank you for playing. Now the interesting part is, as you can see here with this log, the model actually decided to call this tool to declare the winner. So it automatically did that, decided to call the tool, the SDK called the tool, and yeah, we see the result obviously. So as you can see again, what is happening, our request is going through the endpoint to the agent. The agent is retrieving the session history and then sending not only the system message, the user message, the history, but also the tools available for the model. And the model, in this case, decided to use this tool to declare the winner. So we declare the winner, we execute the tool requested by the model, and then send again to the model the system user message history, the tools and the results of the tool, and then the AI response. And then we store, of course, the user message and the AI response, and then we reply back. So as you can see, all of this is provided by the SDK, all this interaction with the LLM model. So before we actually move onto some more complex samples, I just would like to showcase some of the things that some of the options that we have available here on when building the call to the LLM. One is obviously to define the model that we want to use. So the reason why we don't have it here explicitly is because we're using the application conf to configure the model. So in this case, we're using OpenAI. The model name is GPT-4o Mini. But you can also define it directly on this call by providing an API key, model name, and different parameters, or of course using a different provider that you prefer. And another interesting thing I'd say is that we can also map our responses from the model into something else. So here we are replying with a string, but we can definitely transform this string into some other object, for instance. So let's say if I have this response type, then I could do something like this. Of course, use the method reference here, and then use it here. So I can transform my string that comes back from the system message and into a new type that I return back to the endpoint, of course. Then here I'd have to do some this or treat it in any other way. Okay, so moving on to the next topic is multi-agent orchestration. This is a very interesting topic actually, and a little bit more complex, so we won't be able to implement it here, but basically agents can collaborate on complex tasks, and Akka supports orchestrating multiple agents so they can achieve complex goals. Each agent usually performs a single well-defined function, and then multi-agent workflows can be either predefined with some static steps or dynamically generated using a planning agent and the registry we provide. We'll take a look at this in this multi-agent sample. So, okay, so I'm actually checking the README of the multi-agent sample because it has this nice diagram. So in this sample, basically we use different agents to come up with the plan for an activity. So an example of the flow is something like sending a message saying, I do not work today, I'm in Madrid, what should I do? Be aware of the weather. And now we can see that we use a Akka workflow, and we have basically two agents that one is responsible to select the possible agents that might be able to respond to this question. And the next one is, given the specific agents that I have available, I want to actually create a plan and then execute the plan. So yeah, the workflow starts by using this agent selector to get a list of agents that might be able to help us with this task. And then we ask the execution planner to create this execution plan. And then when it returns the plan, we basically will execute that plan and call the specific weather agent to know how is the weather in Madrid, and then the activity agent so it can suggest us some activities in Madrid with this weather. Okay, and then we summarize the responses and send it back to the user. Okay, so some of the things that we provide to make this possible is, let me open this weather agent. So we provide this agent description annotation, which we didn't use on our simpler agent, but here it's very useful because it allows you to describe the agent, and also it allows you to tag the agent as a role. And then, so when we are providing information to this selector agent, for instance, we can use this agent registry to grab all the agents with a specific role and then pass this on as a list of agents available for this selector agent to be able to select which agents might be useful to accomplish this task. Yeah, so this was just a quick go through this sample, but if you want to know more, just check it out. Coming back to our the next topic that we have is the retrieval-augmented generation. So agents are able to enrich prompts with additional relevant content and context retrieved from entities, views, mainly using the component client that we offer, which allow you to call different components to retrieve information or execute some commands. And we also integrate with different streaming sources, for example, brokers, that you can use to pull in information that you then can add to the context of the model call. And of course, in RAG, it's also very common to use vector database, and there you can use your client of choice to load that information from the vector database and add that on to your user question. So to check this, we have this sample ask Akka agent, which I'm opening right now. Okay, so this is also a very interesting sample that you can have a look. And so, and this sample is actually interesting as well because, of course, it uses the workflow for indexing the information, but also on this agent we also use this stream effect. So this is where you can actually stream the data directly from the model into a client instead of doing a typical call. You can just stream token by token your information out. So this is an example of doing that. And here's the enriched question. So we're basically using this class knowledge where we're fetching our vector database and then augmenting our user question with this information. So yeah, this is also a very cool sample. If you're looking to see how to do a RAG, this is a very interesting sample to look at. Okay, so just some final notes to wrap up. Agents don't live in isolation, so we have a lot of other things that we provide that are able to integrate directly with agents, and a lot of other features as well that I didn't mention here, just as MCP support, gRPC, JWTs, ACLs, broker integration, etc. So really, if you want to have a look at all the different features that are available, please go to our documentation at doc.akka.io. And yeah, as I mentioned previously, if you want to look at these samples for RAG and streaming, And for multi-agent orchestrations, here are the links. Don't forget that all of this is already available from Akka SDK version 3.4.0. So yeah, just go ahead and have fun. Thank you.